short video on 4-point FFT computation using the butterfly algorithm. So we have a given sequence x of n that is equal to 1, 2, 3, 4. It's a discrete signal, and we want to find out the FFT by using the 4-point FFT algorithm. So the first step here is you have to get the order of the input. Basically what you're trying to do here, you're going to split into even and odd components. You can also use the bit reversal rule to get the corresponding sequence. So here is the bit reverse sequence. For the 2-bit input, or the n is equal to 4, the data with n is equal to 4, we have totally 2 bits, and these 2 bits we are going to organize. It is 0, 0, 0, 1, 1, 0, 1, 1. We need to do the bit reversal, and after the bit reversal, 0, 0 will be same as 0, 0, 1 become 2, 1, 0 become 1, and 1, 1 become 3. So these are our input to the system, or to the butterfly model. So these are our input. We have n is equal to 0. At n is equal to 0 we have 1, n is equal to 1, 2, n is equal to 2 we have 3, and n is equal to 3 we have 4. These are the numbers. So therefore the corresponding numbers are 1, 3, 2, 4. 1, 3, 2, 4 is the input to the butterfly algorithm. Now the first step is what we should go for: n by 2 DFT. N by 2 DFT, since the number of inputs are 4, so we require to design the 2-point DFT. N by 2, which means 2-point DFT, 2P DFT module. So we just first stage, the n by 2, or the 2-point DFT. So the first 2 lines must be connected, 2 inputs must be connected with a cross butterfly connection. So with the coefficients w2 power 0, which is 1, and w2 power 1, which is minus 1. Why w2? Because this is a 2-point DFT. Next stage, we have to find out the 4-point DFT, and before that we just want to mark the output value. So we are marking the outputs are G0, G1, H0 and H1. Next step, we want to do the N, which means 4-point DFT. Okay. So we have implemented the 4-point FFT here, and these are the coefficients, the trivial coefficients: w4 to the power 0, which is 1, then w4 to the power 1, w4 square, and w4 cube. The corresponding values are minus j, minus 1, and j respectively. Now the output connections, or the output terminals, are x0, x1, x2, x3, which will give you the FFT signal at the output. Now the sequences are at the output. We have to find out the values of G0, G1 at the first stage, same way H0, H1. Then the second phase, we are going to find out the value of x of 0, x of 1, x of 2, x of 3, with the inputs and the corresponding multiplication factors for the trivial coefficients. So we found the value of G0. G0 is obtained, this is G0, that is obtained x0 and x2, because x0 is direct, and h0 through the coefficient w2 power 0. Since it is 1, the G0 is obtained by adding the x0 and x2. The same manner we can calculate G1. X0 is direct, whereas x2 is through the coefficient w2 power 1, which is minus 1. So this is obtained by subtracting x of 0 minus x of 2. Now same way you can find out the value of h of 0. H of 0 is addition of x of 1 and x of 3, whereas h of 1 is subtraction of x of 1 and x of 3. So we found these values at this stage: 4, minus 2, 6, and minus 2. Now in this next stage, we have to calculate the values of x of 0 x of 0 is obtained by adding g of 0 and h of 0. The coefficient is 1. So it's nothing but simple addition. X of 0 is nothing but simple addition of g of 0 and h of 0. So x of 0 is obtained by adding g of 0 plus h of 0. This g of 0 and h of 0 have already we calculated. So g of 0 is 4 and h of 0 is 6. By adding this, we'll get the x of 0 value. Now x of 1 is obtained by adding g of 1, h of 1 through the the factor w4, which is minus j. So the x of 1 is obtained by g of 1 minus j into h of 1. So we'll get minus 2, which is g of 1. Then h of 1 is minus 2, while the value of j, the total factor is minus j, so this will become minus 2 plus 2j. We can find the value of x of 2 is equal to g of 0 minus h of 0, which is 4 minus x, which is minus 2. Now we can find the value of x of 3, which is g of 1 plus h of j into h of 1, and the value of h of 1 is minus 2, so this will give you a result minus 2 minus 2j. Therefore the final results x of k, that is equal to, and therefore the final result is x of k is equal to 10 minus j minus 2 plus j2 minus 2 minus 2 minus 2j. The first number which shows the nth zeroth value, that is correspond to DC component as far as the frequency the transform is concerned. So DC value will be located at 0, and as you go towards the left, you will find the high frequency components. So this is the DC component, and these are the other high frequency components. So 0 is the DC value, and the right values are high frequency components. So now we'll try to do the inverse FFT using the butterfly algorithm. For the previous case, actually we got 10 minus 2 plus 2j minus 2 and minus 2 minus j, and we are going to apply the inverse FFT and to verify whether it can get the original result 1, 2, 3 and 4. So the main point to remember that the inputs are of the correct order. In other words, no need to apply any kind of bit reversal, but output will be in the bit reversed order. Okay, so which means you will find the even components, which is 0, 2, then the odd components, which is 1 and 7. So now in the case of inverse FFT, we are supposed to start with 4-point DFT, just opposite of the FFT algorithm. So we had to follow the reverse order. The first is 4-point FFT. The coefficients are there is also a difference in the coefficients. The lower two means for the x2 and x3, the coefficients are minus 1, and you have to introduce the coefficients w0 and w4 to the power 1 at the output of the node. So this is one of the important point to remember. We have to ensure that these coefficients are outside the node. Now we are going to represent, since it is inverse FFT, we follow the small letters G0, G1 for the first two and H0, H1 for the last two. We will try to find out the value of G0, G1. So in this case, the G0 is obtained by simply adding x of 0 and x of 2. This is G of 0. This is obtained by adding these two, and both coefficients are 1. So direct symbols summation x0 plus x2. So if you add that, we'll get x of 0 is as we have. So these are the input. The first input is 10, second input is minus 2 plus 2j, third input is minus 2, and fourth input is minus 2 plus 2j. So we'll get the value of G0 is equal to 8. Similarly, you can find out the value of G1. G1 is obtained by adding x1 and x3. So when you add x1 and x3, we'll get minus 2 plus 2j, minus 2 minus 2j. So we'll get the answer minus 4. So we can also find the value of h of 0 and h of 1 by using the rule x of 0 minus x of 2 and x of 1 minus x of 3. We'll get the values h of 0 is equal to 12 and h of 1 is equal to j4. Now we'll move on to the next phase. So in this phase, we are going to implement 2p DFT, which means that two lines to be selected, and the coefficients are 1 and minus 1. The power will be w2 power 0, w2 to the power 0, and w to the power 1, w to the power 0 and w to the power 1. This will give you 1 and minus 1. So the top will be 1, bottom will be minus 1. So then we can find out the values of x. Now we can find the value of x0, g0 plus g1. So g0 plus g1 will give you x0. So we can find x0, g0 plus g1, which is 4. We can also find x of 2. X of 2 is nothing but g0 minus g1, which is 12. We can find the value of x of 1. X of 1 is based on h of 0 and h of 1 with a direct subtraction. Sorry, x of 1 is obtained by h of 1 and h of 0, adding h of 1 and h of 0. So this will give you 12 plus j4, j times j4. So this will give you 8, because j times j is going to be minus of 1. There was a minus sign before. The j into j will be minus, and that because of the minus 12 minus. So in this stage, we'll have 12 minus 4. That will give you 8. So similarly, you can also find the value of x of 3, that is equal to h of 0 minus j into h of 1, which is 12 minus j times 4j. So j times j is going to be minus 1, minus 1 plus 1 will be, minus 1 and minus will be plus 1, and 12 plus 4 will be 16. So we'll get the answer here. Now we can find that the value that we found was 4, 12. Now at the output, the order is not the correct sequence. It is the rotated bit reversed order. So accordingly, we can find the correct sequence is x of 0, x of 1, x of 2 and x of 3. So accordingly, we'll get 4, 8, 12 and 16. These numbers are basically to be divided by the total number of samples in order to get the original value. So since the sample size is 4, each of these number divided by 4, so we'll get the answer, the final value of answer 1, 2, 3 and 4. So this is the original result what we have in the first stage. So the step is exactly the result is exactly the same. So first we have done the 4-point FFT computation for the sequence 1, 2, 3, 4, and we obtained the corresponding the FFT values. Then feed those values to a inverse fast Fourier transform algorithm, and we obtained the same number 1, 2, 3, 4. So this shows that if FFT and IFFT, they are reversible processes.